Yeah, good morning. Welcome to the session. So in this today's session, I am going to deal with the outline of the subject power electronics. This is an fifth semester for site 21, and the subject code is 21EEET 5020, and this is having 3 credits. And we'll move on to the course objectives in this. So here we have 5 course outcomes in this course. So one is to study the static and dynamic characteristics of the SCR, power MOSFET, power IGBT. So from this course first objective, we are going to study the static and dynamic characteristics of SCR, that means silicon control rectifiers, or you can call it as thyristors. So along with that, we have power MOSFET configuration and IGBT. So here also we are going to study the switching characteristics of the two power devices. And when come to the second objective, to understand the operation of single phase controlled rectifier. So here the thing is, we are going to convert the AC to DC conversion. That means a fixed AC is converted into variable DC by using the single phase controlled rectifiers. And in this module, we have various control strategies and converter modules to control the AC into DC, and we are going to study one by one, like uncontrolled rectifiers and controlled rectifiers. So in this module, similarly we are going to study the operation of 3-phase controlled converters. When 3-phase input is given to the circuits, different circuits like bridge circuits and fully controlled rectifiers or half bridge converters, whatever the converter topology. So we are going to convert the 3-phase AC into our variable DC, and there are different circuits. Here we can see 3-pulse converters, 6-pulse converter and bridge configuration in this module. And move on to the fourth objective. Here we are going to understand the operation of the different types of DC to DC converter. Here also 2 modules are involved in this. One is DC to DC converters and another one is AC to AC converters. The first module indicates that the DC, a fixed DC is converted into variable DC by changing the time periods. That means we can change that on time or off time of the pulse. So when come to the other module, that is AC to AC conversion, here the pure fixed AC is converted into variable AC by different AC voltage controller circuits or regulator circuits in this module. And we'll move on to the fifth objective. In this we are going to study the operation of different DC to AC converters. Here a fixed DC is converted into variable AC. So there are again series and parallel circuits and bridge circuits involved in this converter topologies, like DC to AC. And we will go with the module wise. So the unit 1 indicates that the power semiconductor devices. Okay, here we have power semiconductor devices. So in this power semiconductor devices, we are going to study the SCR characteristics, that is silicon controlled rectifier. And to understand the SCR characteristics or SCR working operation, so we are going to analyze the 2 transistor analogy in this module, and along with that the performance of SCR can be obtained by analyzing the static, that means V and I characteristics, VI characteristics. Along with that, we are going to study the dynamic characteristics, that means switching characteristics of the SCR in terms of turn on and turn off mode. So in order to get the turn on and turn off of operation of the SCR, there are various circuits involved in this silicon control rectifier, and there are the various triggering method to turn on the SCR, that is gate firing circuit. So we can see here resistive and capacitive and other UJT. All these 3 are the gate firing circuit for the ACR switch. So along with that, in the first module we can study the snubber circuit in order to protect the ACR while operating in the circuit. Similarly, we are going to study the power MOSFET and power IGBT characteristics in this module. So here also switching characteristics and VI characteristics can be analyzed for both the MOSFET and IGBT switches. And we will move on to the next one, that is unit 2. It deals with the single and three phase AC to DC converters. So first we will go with the single phase half controlled converter, and here before going to this single phase half wave controlled converter, we will study the uncontrolled converter initially, then move on to the controlled rectifiers, that is AC to DC conversion. So we will analyze in this R and RL load with and without freewheeling diode configurations. So what is the difference between the output voltage of R and RL loads along with the freewheeling diode concepts. Similarly, the bridge circuit with fully controlled converter with a midpoint configuration and bridge configuration. So with and without with R load and RL load along with RLE load we are going to study in this module. So for each and every converter module we are going to derive the expression for output voltages to analyze the effective conversion of the converter. So in this module, so in the following we have a single phase semi converter with R and RL load and RLE load, and followed by harmonic analysis. So we are going to derive the harmonic analysis equation for each and every AC to DC converter. So we have some numerical problems in this module. The similar way we are going to apply the three phase input to the converter topologies. So where we can convert the three phase AC into DC, that means initially it is a fixed AC then converted into variable DC. So for that we have different configurations here. One is pulse, 3 pulse and 6 pulse converter configurations, and another one is bridge configuration to derive the voltage average voltage for the R and RL loads in this module. And next one is to analyze the DL converters. Here we are going to analyze the circuit operation only, not with the derivation of the output voltages. So DL converters operates in the two modes. Converter 1 and converter 2 are connected together back to back. Then we will operate with 180 degrees of angle. So that means alpha 1 plus alpha 2, it's 180 degrees. So we are going to analyze this DL converter. Now move on to the third unit. So unit 3 deals with the, just a minute. So unit 3 deals with the DC to DC converters. Generally a fixed DC is converted into variable DC. So for that, what are the control strategies we are going to use to change the on time or off time of the pulse? So the control strategies are analyzed in this section, and second followed by the buck converter. So the importance of the buck converter is nothing but to step down the voltage levels, and we are going to analyze the significance of the boost converters, where we can have we can increase the level of the voltage, where we can, like solar panels or any other way other areas where the low voltage has to be increased to the high level. So one more buck boost operation is very essential in the electrical vehicle kind of things. So all these DC to DC converters are analyzed in this third unit. And move on to the fourth unit here. So move on to the fourth unit here. We will start with the introduction of single phase and three phase bridge inverter with R and RL load. So generally what happens here, DC is converted into AC, that means fixed DC is converted into variable AC. In that we have three different inverter configuration to produce the single phase and three phase bridge configurations with R and RL load, and three phase square wave inverter also we have to analyze in this module with 120 degree conduction and 180 degree conduction mode of operation. And there are different types of inverter configurations like PWM inverter configuration and quasi square wave in pulse width modulation techniques we are going to incorporate in these inverter configurations. Similarly, the sinusoidal pulse width modulation technique also we are going to discuss in this module. And at the end of this session, this module we are going to discuss about two important topics, that voltage source inverter and current source inverter. So this is the outline of the DC to AC converters we are going to discuss in this module. And the fifth one is AC to AC converters. Here we can have a fixed AC is converted into variable AC by using the AC voltage regulators or single phase AC voltage controller with R and RL load. So here also we are going to derive the voltage equations or RMS equations for R and RL loads. And the more this is one of the one way of taking the AC voltage controller operation for R and RL load. And another way of doing the AC voltage controller by taking the track. Track is a switch. So by taking the track also, that means it's an anti-parallel thyristor concept. So by using this also we are going to analyze the AC voltage controller concept with R and RL loads. And we are going to derive the RMS load voltages for this particular AC to AC controller voltage control circuits. And especially because we are dealing with the AC, then we are going to take the concept of power factor in this. And at the end of the module of fifth from AC to AC converters, one more is cycloconverters, where we can change the frequency of the AC to AC converters. So that means fixed to variable frequency converter operation can be analyzed in this module. So this is the outline of the course Power Electronic in this fifth semester. And from this content I can say the students are going to get the knowledge of analyzing the static and dynamic characteristics of ACR, and the students are able to analyze the power MOSFET and power IGBT significance in the power electronics and controller units. And also students are able to explain the operation of single phase controlled rectifier with uncontrolled and controlled rectifiers. And the third one is the outcome of the third module is to analyze the three phase controlled converters with 3 pulse, 6 pulse and bridge configurations and their expressions for voltage and currents. And the fourth outcome of the course is to analyze the operation of different types of DC to DC and AC to AC converters in this particular module. So the last outcome of the course is to explain the operation of different types of DC to AC converters, that is inverter operations we are going to study here. And these are the outcomes of the course at the end of the semester. And there are the books given in this, that is Power Electronics Circuits, Devices and Applications by M.H. Rashid. This is the standard author book, standard book by M.H. Rashid, Pearson Publications. And one more is suggested Power Electronic Essential and Applications by Umanand. So this is from Valley Publications. And other reference books are suggested here. that is by Power Electronic by Vedam Subramaniam. This is one of the best book. Similarly, Power Electronic by VR Murthy and Power Electronic by PS Bimra. This is the one of the standard textbook, can be referred for from the Kanna publishers. And one more is Power Electronic Converters Applications designed by Ned Mohan. So these are all the important textbooks can be referred for understanding this content of Power Electronic. So yeah, this is about the session Power Electronic introduction and outline in this session, and we will meet in the next session with the introduction of ACRs.